Welcome to the 5 minutes video of Object Recognition with Continual Open Set Domain Adaptation for Form Robot. My name is Iki Kishida, and I'm the first author of this paper. Let us summarize our work in 5 minutes. The environment and the types of objects are greatly different from form to form. It is very difficult to pre-train a recognition system that is universally applicable to any forms. Therefore, we need an efficient framework to train the recognition ability of robot in each environment without much burden for end users. We consider that displaying object in front of robot is one of the user-friendly scenarios of teaching object for form robot. However, to take account of this scenario more realistically, we claim that domain adaptation, open set recognition, and continual learning are important and should be considered simultaneously. First, domain shift problem. It is difficult and not realistic for end user to do annotation for training, such as putting bounding boxes. Easier way of teaching a robot would be to show an object one by one in front of its eye camera. However, this means that huge domain shift occur between the image of handheld object and naturally arranged object. Second, open set problems. In a real environment, there should be many unknown objects not presented in the training phase. The recognition system must be able to distinguish such unknown objects from known ones. Third, catastrophic forgetting. As novel objects continually appear in our daily life, the recognition system should be able to update the knowledge timely to handle them. So we need an efficient framework to incrementally train the system without using many computational costs. Although there have been many datasets for visual recognition on robots, to the best of our knowledge, none of them have covered the mentioned 3 problems simultaneously to recognize naturally arranged objects in a room by training with handheld ones. On the basis of this motivation, in this paper we propose the COSDA-HR dataset. The assumed scenario is that we present a robot with novel handheld objects every day for training, and the robot adapts the visual knowledge from the handheld image to the home environment by using the image explored in the home on that day, where many unknown objects also exist. All the images in the COSDA-HR dataset are captured by RGBD sensor of HSR. There are 16 supercategories, and each category has 10 different instances. Thus, there are 160 classes in total. Figure 1 shows some example of source images. We show each object to the HSR in front of a uniform background while rotating it by hand. As a target images, we manipulate the HSR and collect images in an experimental home environment, as illustrated in Figure 2. We conduct 22 explorations, randomly changing the objects and their location for each exploration. Overview of the task pipeline in the COSDA-HR dataset are shown here. The system is given some labeled handheld images as the training data of the source domain, while it also explores the environment and detects object-like region from unlabeled target images. Using the source and target data, the system performs domain adaptation and recognition under the open set situation. This procedure is incrementally repeated using n different subsets of classes. We demonstrate that simple combination of each of the state-of-the-art methods can only achieve 70% mean class accuracy, when the accuracy of the unknown class is larger than 90%. And it is far from satisfactory result. This result implies that it is necessary to study algorithms to deal with multiple problems simultaneously, instead of solving each problem separately. Summarization of our paper are shown on this slide. Our code and the COSDA-HR dataset is publicly available. Please come to our session if there are any questions. Thank you for listening.